So let's talk a little bit right now about these guys, the standard brush and the clay brush. And I want to make sure you understand what the difference is between them. You know, why one is better than the other and when to use one. Let's go into Lightbox. And let's start with the standard brush. And I'll show you, this is a sculpt I did right before class. Nothing major. It's just like a 15-minute thing. It's still getting worked on. And we'll go all the way back in time. Okay. So a simple sphere, I use the move brush to start pulling things out. And then start to push form in, smooth it. But what I want you to notice is how soft everything is. Everything just kind of maintains this soft vagueness. And stays really, really soft and really, really vague for a long time until we start to define edges and shadows and give these little indents with basically a knife tool, so to speak. So the standard brush being the first brush, it's really awesome. It's got a lot of potential. So let's go. I'm going to continue working on this guy. Make sure I'm all the way at the end, yeah. But it's got limitations. It's what we call topology dependent. The form that it creates is not the same no matter what the topology is. And the best example, I think, let's get a little excitable about this. Let's see if that one works. So standard brush, let's go up. And where are we at? How many polys? Okay. So when you start sculpting the form, you saw I just made a couple of strokes in here, and then these guys started to move towards each other. The form, the standard brush uses what they call the surface normal. And we'll start to move along the surface normal, really working quite well in some cases, but not in others. The clay brush is what we call topology independent, and that means that no matter what the normal is, it just shoots that out in one direction. One direction. So I can come in here and nothing folded in on itself except for a little bit right in here. Everything just moved straight out. And that ability for it to move straight out and be topology independent is a really significant it's a really significant improvement in the algorithm. If you're wondering where you get this undo, let me just return my interface to the standard. Under Edit, Tool, there's this undo counter in here. Really cool way to keep track of stuff. Plus, you also have this right here. I'll make sure you have a nice little lecture on that, but you can drag that back and forth. Okay, this separation in algorithms is important because what you'll notice, whether you've seen my tutorials before or not, you'll see this, but let me just hover over a couple of brushes. Right now I'm hovering over Trim Adaptive, and even though it's a different name, you can see its base type is clay. Trim Dynamic is clay. What else is clay? Form Soft, that's a clay brush. So I'm not getting in and explaining these brushes too much right now. We're going to do that in week 3 or somewhere around there. But what I want to do is just kind of introduce you to this type so that you can start to experience this. Planar. Let's check this out. Let's go into Planar. And yeah, there we go. Look what this brush is doing. This was one of their first efforts to really getting hard surfaces and really working those. Let me undo this until we have eyes, and you'll see it. Voila. That's what they call the planer brush. And if you hover over it, you see that its base type is clay. So this is doing the exact same thing, supposedly, as clay buildup, which if you've used clay buildup and you try to get that exact effect, something's not right. How is it that that planer brush is the same as this brush? I mean, this is quite a difference. And it's been a while since I've got to play with these. I've forgotten how kind of cool they are. It's the feature framework that moves things from one side of the spectrum to another. It's these features. It's this brush system. What is it? What are the items? How do you alter and create your own planer brush, which you can do. You can totally create your own planer brush. You just need to know what those settings are. What do you change in the orientation? What do you change in samples? What do you change in modifiers? What about depth? Notice the depth is set to 0, but if I go to clay buildup, my embed is set to 20. What is Z-add doing? Well, Z-add Z-sub, and then let's go to the planer. Look, Z-sub is activated automatically for it. All of these things impact what we end up sculpting, and that's exactly what I want to make sure you are learning and able to do yourself. But we're going to get there little bits at a time. The key thing, and what I really want you to understand about this difference between the clay versus the standard, is that it's the algorithm. Okay, that's the key thing. It's the base type, and the difference is the topology independence. As soon as a brush became topology independent, then it could basically copy the standard brush, or it could just lop parts off, like planer brush does. Because it doesn't matter what that topology is doing, it's ignoring it. This was a major innovation. Topology independence should have been celebrated in our industry. As soon as this algorithm was developed, I don't know, maybe even invented by Pixelogic, then we should have all had a big party and celebrated what's really now going to be the future, which is a whole bunch of these new tools and stuff like that coming up. And Kathleen's asking, does topology independent mean it's ignoring normals? And yeah, that is a part of it. It's absolutely ignoring normals, but that means that it has to find other things, because that normal calculation is still part of it. And by normal, we mean what's the orientation? So you still have to have some element like this in the calculation, and topology independence means that they've been able to substitute it with something else, or they've been able to average enough of them, or work with the average so that they were able to extract one big direction. And if we look at planer, you can actually see that. If I use planer right here on the side, notice that that's going to face one direction. What happens if I use planer here? Well, that's going to introduce you to, and you can see the brush move. If I make it smaller, you can see it move a little bit more. See how it points down? Well, now everything points down. So it's not so much that it ignores the normal as it handles it differently. And what does it do with those polygons? It just jams them in there. Pushes them all together and does the best job that it can. And that's really the beauty of topology independence. So I'm so glad that came out. What does topology independence do with those topology points that get in its way? Well, that's what the algorithm is built for. It tries to create a plane in 3D space. And then it tries to shrink wrap or magnetize all of those vertices to that plane in space. And it has to do that, and this is really important for those who teach ZBrush, it has to do that at 60 frames a second. Because that's how fast ZBrush is displaying stuff back to you. We're really in a real-time game when we're inside of ZBrush, interacting with our Wacom, with the environment, having that played back to us at 60 frames a second. So ZBrush has to calculate math. It has to do the math to magnetize them to that plane, do all of that so that it's happening in real time for us and allows us to feel like we are free and creating. This moment that we're talking about right now, where it's going at 60 frames, it's doing this math, it's working with this algorithm to create this 3D plane in space. This is the core of why ZBrush is so awesome. They have this down. They work to solve this problem so that it happens fast enough for us to do it in a real-time environment so that we never feel like we're in a computer, so to speak. We always feel like we're just creating. If you were to go into a program like Maya and you start working with their Sculpt tool at higher polygon resolution levels, things start to slow down. ZBrush is built so that you never really want to be aware of your hardware. You want to always be thinking about what you want to create. So that was a really important topic that I wanted to make sure you understood, which is the topology independence, or really the clay versus the standard brush. And these two different approaches to creating form.